Let's consider this integral that we want to evaluate, the square root of x squared minus 3 over x dx. Now, one way we can solve this is by using trig substitution. So let's draw a triangle. For example, we'll call this angle theta. And now we can express our expression that we want to integrate in terms of a trigonometric function. So we have x squared minus 3 for our opposite side, x for our hypotenuse, and thus by the Pythagorean theorem we have root 3 be our adjacent side. Now we can recognize that sine of theta is going to equal to the square root of x squared minus 3 over x, or in other words, our inner expression that we want to evaluate. But we also want an expression for d of x. So one way we can do that is by looking at our triangle once again. In this case, we can see that if we take cosine of theta, we get root 3 over x. And in this way, we can solve for x to get x is equal to root 3 divided by cosine, or in other words, multiplied by secant of theta. Then when we take the derivative of both sides, we get that dx is just going to equal to root 3, and the derivative of secant theta is just going to be secant theta tangent theta times d theta. So now when we put this black into our original expression, what do we get? Well, we find that our original expression is in reality also going to equal to the integral of sine of theta times dx, namely root 3 secant of theta tangent of theta d theta. Now we can simplify this expression to get sine of theta times secant of theta is also tangent of theta, so we take out the root 3 to get tangent squared theta d theta. Now we can also simplify tangent squared theta by knowing that tangent squared theta plus 1 is equal to secant squared theta. And so what we find is that this is in reality equal to secant squared theta minus 1 d theta. Now, when we're evaluating this, we take each term. So we have the integral of secant squared theta, which we know is going to be tangent theta, minus 1. When we integrate 1, we just get theta, so minus theta, plus some constant c, since we don't have any limits, so it's an indefinite integral. So now what we want to do is we have this expression, but this is in terms of theta, not in terms of our original variable x. So when we're looking back at our triangle over here, we can resubstitute these expressions for our x terms. So this is equal to root 3 times tangent of theta, which is just x squared minus 3 over root 3 minus theta. In this case, we can do theta as the inverse secant of x over root 3 plus some constant c. And so we conclude then that our original integral, the square root of x squared minus 3 over x dx, is just going to equal to, here we see that we have a root 3. So then we can have x squared minus 3 simply minus root 3 secant inverse of x over root 3 plus some constant c. And that is our answer.